All right, welcome on stage, Jonathan. Thank you so much for joining us here today. I think we should start by giving a big round of applause. And the stage is yours.
All right, thank you so much. Today I'm going to present to you our project with the title, or my talk with the title, Building a Data Harmonization Engine on top of Django, the good, the bad, and the ugly. And before I start, just a few words about myself. Hi, I'm Jonathan, as you already heard. I'm based from Hamburg, Germany, and I have a background in PHP and full stack development, worked there in an agency for many years. But I also, still up to date, work with PHP and Laravel framework, for example. And last year I finished my computer science degree at the HW Hamburg, and there I started also to work a lot with Python already, so coming from the data science perspective. And now at the moment I'm working at the Bernhard Nocht Institute for Tropical Medicine. This institute has a focus on research in tropical diseases, and there I am in the Data Snack project, and we are 2 people project where I am the only developer in the team. And you might be wondering, how did I, as a computer scientist, end up in a research institute full of tropical experts in tropical diseases? So what are we building and why? First and all, context data like weather or land usage, census data can provide crucial insights for health professionals. But those information usually come in a variety of different formats. For example, we have georasters, we have vector files, we have plain CSV files, or maybe Excel files, or maybe even APIs and stuff like that. So we somehow need to handle all those different data inputs. And additionally, health professionals usually work on the administrative units of countries. For example, in this case, the country of Tanzania is divided into regions, and the regions are subdivided further into districts. And usually the healthcare system also provides information and data based on those administrative units. So we need to somehow map those different variety of the raw data inputs onto those administrative levels. For example, we are counting facilities in a region, or the proportion of forest inside a regional district. So that we get some nice heat maps, for example, which the healthcare professional can use to further enrich his decision making on. So, and that's actually what we are building. It's a data fusion engine. We call it the Data Hub, and it's an data harmonization engine written in Python, so the user can define data processing in actual Python code. The system is open source and can since the data is based on Python code, the actual data processing routines are reproducible, because, well, you need to just execute the code and then can go from the raw data to the processed data again. Yeah, and this system we built aims to provide to harmonize the data on a temporal and geographic extent. So, and you might be wondering, okay, that's nice, but why Django? So we not only want to process the data, we also want to show the researcher the process data. So for that, we used a web application based on Django. And also we want to enrich the information shown to the researcher by showing documentation and metadata about the data sources we aggregate in our system. And also, I didn't want to mix any programming languages. The data processing is also already fixed to the Python ecosystem due to the large environment of data science and stuff like that. And then I also wanted to create a web front end for it in Python. And so I chose Django. But before that, I also already did a fast prototype, and for this I used Flask, which was nice at the first week, and after that it was quite messy because Flask doesn't provide any, or not that much structure. Also, it doesn't provide, for example, user management of the box, and you had to pretty much do everything yourself, and it was quite messy. And so also that was a further point for using Django, where you have a provided structure. So, and that's actually the Data Hub, and I want to give you a quick live demo clicking around in it. So that's the Data Hub system. It's a live system. For example, we can click around in it, see the different regional shapes and extents for a country. In this case, it's Ghana. And then we can click on the Data Layers menu item and see all the different data sources which are integrated at the moment. And for example, we can get in, search for forest, and then find the forest land cover data layer and see the metadata of this data source, where it's coming from, and then can quickly visualize the data, for example, on the district level inside Ghana. And now we see in the south part there's lots of forest, the blue parts, and in the north of Ghana there's less forest. So, exactly. The data hub is open source, it's self-hostable, so you can put it in your own infrastructure. It's updatable and aims to be a platform for reproducible data. So, and now comes the ugly part. I started to build the Django application for it. And the first thing when using Django was like, I have a background in Laravel framework, for example, and if I create and set up, I have an environment file, which the environment-specific settings, like database credentials, for example. And this is coming from the 12-factor app principle, where you separate, for example, the environment configuration from your actual code. And in Django, I had just the settings PI. And I was like, okay, I need to commit it to version control, but I also have the environment-specific settings in it. How should I handle that? And where should my environment-specific configuration go? And I think the documentation didn't guide me, or the tutorial in Django didn't guide me in anything how I should solve this conflict. And then after a bit of search, I found the Django environment package, which now allows me to create an environment file outside of version control, and then inside the settings PI, load this package, and put in the different variables defined in the environment file and reuse that, and so can decouple my settings PI file from my actual code. The next big part was the Django app, which probably you're all familiar with. For me as a newcomer, this was quite a big roadblock because, the documentation tells you have the project versus the app. The project is the combination of different apps with configuration, and the app is a singular module containing a specific functionality. And I wanted to provide my users with a redistributable out-of-the-box system. So I wanted to redistribute a Django project and not just a single app, because my user shouldn't be bothered with configuring the application. So in the documentation, I only found how to write reusable apps, but there was no word on how do I provide a reusable project for other users. And that was quite difficult for me to grasp, and that's actually how I ended up structuring my app or my project into apps. First of all, I have the data layers app, which contains everything regarding to data sources and data processing. The next app is my shapes app, which contains logic regarding the different shape files and the processing for the geometries of the areas, districts, and shapes. And then in the last, I have an app which is called app, because I wasn't really sure how to solve the problem of having global stuff, template stuff, user authentication. Where should all this stuff go? Because then everything is, has a singular modular scope. Where should global stuff go? And also, for example, the Django documentation tells you and advises you to override the user model in your new project. But it doesn't tell you where this overwritten user model should actually go. And I was completely confused. And also I put it into my app, which is called app. And for me, the system works quite well. But also, I think it's not really in the sense of how Django apps were envisioned to be used, because I not actually structure singular self-containing parts, sondern more of like the mental model of the different parts of my application. And all those three apps have, depend on each other, and I can't really share any of it. So it's maybe not that conventional, I'm not sure. Nevertheless, I got that out of the way and it worked, and now I was faced with the issue of dependency management. And I mean, all Python and stuff, it's a little bit complex. We have requirements, txt, we have pip tools, powertree, PDM, lots of different tools. And I was completely confused on how to organize the dependencies of my project. And I was very reminded of the XKCD comic regarding Python environment in generals. And I was at a loss. So, and always I do what I always do in such a case, I start looking at different projects. And so I started looking at all those different open source projects from which I know they are based on Django. And after looking at them, I was more confused than before, because every one of those tools does something completely different regarding dependency management and deployment. So that was quite confusing. Nevertheless, since I mentioned, so every Django project does its own thing regarding that part. There's no guidance in the documentation, or at least I didn't find it. I had no idea how to differentiate between my first level dependencies and my the whole dependency tree. So my first idea was, okay, I just use a requirements txt and hope for the best. Nevertheless, in this year, I was in a bit of luck because the UV project from Astral kicked off, and now I have found some guidance. I just use UV. I have my PyProject TOML in my project root, define my first level dependencies in there, and then use UV to generate the requirements txt file, which I then can use in my Docker setup as with a classic pip install, and then have a ready to use container for my whole project, which I can redistribute. So far we have the Django project configured, we have structured it, we have redistribution in place. So where's the data harmonization? Well, let's enter the bad part. So now what's the thing? In the Django model, I have my data layer object, which encapsulates the description, the metadata of a data source, which the user can edit via the Django admin, and then is able to change everything. And on the other hand, I have my data layer classes with the actual methods for data processing, which are based on source code and should be created by the developer on the file system, so he can put it into version control, can see the history of developing his processing routines. And I somehow needed to find a way to merge the database part with the actual user-contributed file system part with actual code from the user space I wanted to execute in my system, which is a little bit unconventional, I think. So, and that's what I actually came up with. So I have the data layer model, which encapsulates the data source. It has a key, which is a unique identifier written in snake case. And then I have the actual file on the file system, which matches this ID, also the file name matches the snake case file name. And inside that file, I have the same name, but in WordCap, as all Python classes should be in WordCap, I guess. And then I dynamically have this getClass method inside my model, which then just looks if the file is present and loads it and tries to initiate the class inside the file, which of course this can fail if the file is missing or the class has a bug. So it's a little bit, not that stable. So how to solve that? Well, put on try except clause on it, and then just catch the error if the module can't be loaded dynamically. And then, but if it's all good to go, I then have the downloading and processing routines accessible from the user-contributed source code and can execute them inside the system. And in the actual system, and that's actually how it looks like in the front end for the user. So you will see here the green icons, there the source file could be loaded and executed. And where it's great, there was some sort of exception. We didn't know what exception exactly, but at least we know there's a problem we as user need to solve. So the next difficult part was the researchers. Well, now we have the data processed in our system, and but the researchers are usually doing their own thing. For example, in Jupyter Notebooks, or they rely heavily on R, or maybe they want to just look at the data in Excel, for example. And we somehow need to free the data from the data hub and make them accessible to the user via download or API access, for example. And so Django plus API, the first Google result were, of course, Django REST framework. And I looked at it, and I was like, okay, wait a second. I need serializers, I have abstractions, I have lots of Doku to read and grasp, and actually all I want to do is provide my user more or less with a simple CSV file he can use, because I don't have any write operations going. I just need to read operations. So, and then I looked at the documentation from another library, from the Pandas library, which I already use heavily for data processing. And well, Pandas provides us with a to CSV, to Excel, and to JSON methods based on our actual data frame, which holds the tabular data. So then I had a crazy idea. Well, for example, if that's my API request, I can just identify in my view the data layer I'm requesting. I load the data in a Pandas data frame. Well, and then when I want to return it to the user, well, I just use the Pandas function to create a JSON based on the data frame and return that with a JSON response object from Django back to the user. And the same also works, for example, if the user requests a CSV or Excel file as download, I can also again reuse the pandas library to create those file types. And I just need to create a virtual bytes.io object in memory for creating a virtual file, tell pandas to write the CSV or Excel file into that buffer, and then with the file response object from Django, I return this virtual file to the user, and it actually works. Yeah, so and the last part was front-end. So in my application or in our application, I don't have any state inside the user's inside the user space. It's just viewing at stuff, except for charts and maps, which is dynamic, but also don't have any state. So I didn't want to use any React or single-page application stuff, and I just went with classic Django templates and a little bit of JavaScript to enhance it, or to be honest, a lot of JavaScript to enhance it. I have Bootstrap for styling and interaction, for example, pop-ups on modals. I have data tables for dynamically sorting and filtering tables. I have Leaflet, which we heard before, for the dynamic map parts. I have Plotly.js for time trend charts and stuff like that, and a little bit of D3. And also I use Svelte to create custom elements, which is quite a lot. So I need some way to handle all that dependency stuff. And then I remembered my PHP and Laravel background, and Laravel actually does it really nice, because when you install the framework, this all works out of the box. And then I started to refactor that from Laravel into my Django project. I use Vite for bundling all my assets, and have a custom template helper for each asset, for example, a JavaScript or CSS file, which also supports hot reloading inside the development mode. And in production mode, I just return with the same helper the bundled JS or CSS file. And then, well, it kind of works, and it's really nice. So, but nevertheless, now I told you about I'm not happy with Django. The documentation doesn't tell me what I need to know, and I need to write my own front-end tooling and stuff like that. Why am I still using it? So let's enter the good part, because actually I'm really quite happy with using my decision to use Django in my project. I mean, I have extensive documentation. The only point is I would wish it would be more use case driven, and not only that. I think it's very descriptive in some points and doesn't tell you how to actually combine all the stuff. Also, I have the provided structure. Everything, it's a Django project. Everything has its own place, routes, views, commands. Everyone immediately knows where to look for things. Also, the longevity. I mean, it's there for almost 20 years. Probably will be there for the next 20 years. It has really great stability. I mean, we have security and release process, and maybe it's a little bit of slow, but it also means for at least until now, in the last year, all my minor updates went through fluently. There was no hiccups or anything like that. And also I can build on the community and the ecosystem provided by Django for information, apps, and plugins, for example. And also a big part is the Django admin interface for us came for free, so we didn't have to build anything for the user to actually edit any of the information he wants to, for the metadata and stuff like that. And one part is the last part, I think, which is really, really great. This, for example, is the file structure for a reusable project based on our system. We pull in the dependency, the base image via Docker Compose YAML. We can configure it over the environment file. Then the user can create its customization, its custom data classes with its custom Python-based data processing routines inside a folder. And then one really big part is the user can also just create a new Django app with all the structures it provides, and it allows the user to override the existing templates in the base system, and it also allows the user to create new data input forms, for example, or just custom pages and aggregate the existing data in the system, all by still allowing us to update and provide updates for the system, even through the extensive customization the user might have done in this instance of our system. So thank you so much. That's how I unchained Django for our use case. If you have any questions or want to reach out, you can reach me on following systems. Also, we have a live demo available at demo@datasnack.org. And we have a project page with some more documentation and information about the system, and the whole system is public available on GitHub. You can check it out if you want. Yeah, thanks.
Thank you. We have time for questions.
Oh.
So, if there is a question. Yes?
Hi, thank you so much for your talk. I'm from Africa, but so I was actually excited to see that you used Ghana as your use case. Is there a reason why you chose Ghana?
Actually, there is the Bernard Knott Institute for Tropical Medicine has a partner institution inside Ghana in Kumasi, and because of that reason, we have existing projects based in Ghana, and for that, we have the use case of providing data aggregation for those projects inside Ghana.
Yeah.
You mentioned a lot of different formats for input data.
Yes.
PDF, all kinds of wonderful things. Can you talk a bit about how you manage that?
Yeah, that was the easy part because, well, it's also a little bit of cheating because we provide the user with the hooks in the data layer class for downloading the raw data and processing it. And of course, we provide the user with some guidance on how to download the data and where they will be stored. And also, for example, for Dutive, we provide and aim to also provide for different data sources to provide boilerplate code and best practices for handling those data types. But in the end, the user can just define his complete data processing inside this Python function. And so he can do anything Python will allow him to do. Okay, to come back to your question, for some data types, we provide ready-to-use templates, which you can put your custom data in. And if that, for example, for Dutive processing or for vector file counting stuff when you have location data, for example. And for everything else, in the future, we try to build more and more examples and provide guidance on how to input different data types. But in the end, if your data type is not yet an example, or is provided, you can just write Python code and do it yourself.
Thanks for the talk. I saw that you serialize some raw data to the users. So while you are doing this, have you experienced any timeouts because of the size of the raw data?
You mean the quick demo time with the heat map chart, or?
I remember a CSV exporter, like you create some kind of virtual file on the fly.
Well, we have no timeouts until now. But of course, if the data ingested into the system is really, really big, then probably there will be some timeouts in the future. I think at the moment I have just put in Nginx the timeout value to infinity. So that's not had yet become a problem until now, but I'm expecting it will be somehow coming up in the future, and we probably need to find out how to handle that.
Any more? Yeah, there is a question in the front.
Thanks for a wonderful talk. What unexpected feedback have you got from your users?
They all liked it until now.
Oh.
But no, to be honest, that's actually when we present to our peers in the institute or to other people the project, they are often quite like, wow, we need to have this. There's nothing else we can use to provide that information and the data aggregation. And so that is so welcomed in those projects. That was irritating to me, because for me, from the computer science stuff, I mean, it's a big fancy Excel table with nice visualization on top of it. So that was also, for me as a technical person, that it was quite confusing sometimes.
Another question, and this time at the other end of the room, Emil.
Hi, thanks for your talk. I like how you're now the third person today to mention Leaflet, first of all. Secondly, you mentioned that you used D3 for data visualization, and I wondered what specific parts you've been using, because in my team, we've been using that kind of, and we found it really challenging for multiple reasons. But yeah, I was just curious what you've used.
I didn't know the part actually, but for example, in this case, to create this map, I load the GeoJSON from my database, from my API to provide the GeoJSON, and then I load the raw data from my same API, and then on the client with D3 create the color scale based on the actual data, and then use in a loop to fill all the geometries from leaflet. And there I use the D3 function to get the actual color which is needed for the correct representation.
Yeah, also a question about visualization is like, so you have the geographical one, but you also have other visualizations, right? Or is it just geographical?
It's also the time trend. So for example, this is based on Plotly.js, where you can see this data source is available for 5 years, and we can then extrapolate the time trend change over the available dates of the data source. And there we use this line chart stuff.
Which brings me to the next part of my question. Have you at any point considered to use data visualization, ready-made data visualization app instead, like Streamlit or Panel, or there's like a whole world?
You mean for the client stuff?
For the data visualization user interface?
Not until now, to be honest.
Thank you for all the good questions. And I think that's it. Thank you so much for the great talk. I want to say that